All right, guys. So here we are. We're going to be talking about macromolecules. These four. This is going to be a bit of a long video, so tuck in, find that pause button when you need it, and take a break. Okay. Um, but we'll take a little bit of time just for the quantity of information that is there. All right. So we're going to go through these, all four of these. Once again, we talked about it in another video, but all three have carbon, hydrogen, and oxygen in there. Okay. These two only have carbon, hydrogen, oxygen. This one has nitrogen. And then we got phosphorus here and sometimes sulfur in the last two. All right. So, carbohydrates. This is usually used for quick energy, relatively quick energy. We have different types of carbohydrates, of course, that we know of. So, like things like Gatorade and stuff like that, drinks, sugar in your coffee, which at your age you shouldn't be drinking, but I'll do anyways. Um, that's going to be super quick. Then the breads, pastas, and other things are going to be relatively quick. Now, if you know anything about nutrition, we talk about like slow burning carbs, fast burning carbs, blah 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 blah. In this instance, and for this thing, these are fairly quick energy. Okay. Once again, they're made up of carbon, hydrogen, oxygen. They are in a 1-to-1 ratio. So if I had 7, all right, carbons, that means I'm going to have 14 hydrogens and 7 oxygens always. They're usually plant based of some kind. There are some animals, forms of carbohydrates, and they use them in animals, and we use them for structural purposes. So they're made up. Remember, I told you you're going to have to be, you need to know what the monomer that makes up the polymer. So the monomer is, this one's kind of easy in my opinion, is monosaccharide. Right? Saccharide means sugar. Okay. So mono means one sugar. Okay. Disaccharide would be 2 sugar. This would be things like lactose, fructose. All right. And then polysaccharides are many much like 3 or more. All right. So what's going to fall here is glucose. So you'll notice at the end of each one of them, they have an ose. So if it is a carbohydrate, it'll end in ose. Okay. So short chains, very small ones that your body uses pretty much instantaneously would be glucose, lactose, fructose, things like that. Disaccharides will be a little bit slower, but still pretty quick. Polysaccharides are the one that's really gonna take a little while in our body to use. Okay? So monomer is monosaccharide. Polymer would be polysaccharide. Okay. Like I said, it ends in ose. We can find a multitude of examples of these. Um, they served as storage and building materials. In animals, we find it in starch and glycogen, which is stored in our muscles. In plants, cellulose, chitin is another one that you will also find sometimes in animals as well. Right? It helps them with their exoskeletons and things like that. So you find it in both plants and animals. Cellulose, all right, this is also called fiber, at least for us and humans. So we can't digest it. So that's why they say you need to get your fiber. That way you make sure you go poop every once in a while. All right, lipids. So this is our second group. Okay. Once again, carbon, hydrogen, and oxygen are the elements that make it up. This one is made up of 2 monomers to make the polymer. So monomer 1 is glycerol or glycerol. You see it pronounced either way. The monomer number 2 is a fatty acid chain. So we're going to talk a little bit more about these, but they're just called fatty acid chains. We can have Saturated and unsaturated, we'll talk a little bit about that later, but right now, make sure you understand that these are the monomers. Okay? Fats are important. Okay? You cannot live a life with zero fat. Okay? It is impossible. Fat literally makes up every cell in your body. Okay, so now can we be wise about what fats we eat and don't eat and stay away from and blah 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 blah? Yes, 100%. However, you cannot have a zero fat diet. It will not be good for you. Okay. Now, in humans, it also serves, it serves tons of roles, um, hormones, uh, protection in the body of the organs itself, provides cushion around your organs. Some folks like me, we have a little bit too much cushion, but they provide support for your organs as well. This is long-term energy. Now, long-term, like we talked about in the last one, which is short-term, short-term could be a day or two. Long-term energy, this is the one that's going to break down, take a much more time to break down, and takes a lot longer to use. If you're looking at calories, which is a unit of energy measurement, right? Right. A carbohydrate is 4 calories per gram. Fats are 9 calories per gram. Okay. So they are over double the amount of energy per same size. Okay. So these take longer to break down. They last longer. Your body actually wants to kind of keep them due to evolutionary history. We're the only species that's like, hey, we don't want to get too fat. Most animals are like, hey, I need to bulk up a little bit because I don't know when I'm going to eat again. So we're kind of the only ones that like, oh, we got too much stubborn fat on. I got to go on a diet. Most animals in nature are just trying to not die. So they're not really too worried about this kind of stuff. Right. So we talked about this a little bit with the other video with water and why oils and waters or lipids and waters don't mix is because they are non-polar. Okay. So if we look back at this diagram, when we had our water molecule, we had oxygen, hydrogen, slightly negative, slightly positive. Well, here there is no charge. This whole molecule overall has no charge. So it makes it fairly difficult to mix in water. It is what we call hydro, water, phobic, fear of. So hydrophobic just means literally fear of water. Okay. So they just don't mix. They don't, since they're nonpolar, don't have a charge. They don't mix really whatsoever with water and other liquids very well. We have 2 types that we'll talk about. We talk about first with a saturated fatty acid, a lot of times called the bad one, and then unsaturated fatty acid, sometimes called the good fat. Okay. Now, that's kind of a misnomer because you need both in your body. We find that too much saturated fat can lead to heart disease and other things like that. So we try not to just gobble down, all the saturated fat we can find. But it is not inherently unhealthy. You need both kinds. Okay. A lot of times you see saturated fat coming from animals, and a lot of times this is from plants, things like seeds, nuts, avocados, all those kind of stuff. Now, in a saturated fat, what it means when it says full of hydrogen is here is my, so we got I'm just going to control the one right here. So here's my glycerol. Okay. And here's my fatty acid tail. So I'm going to draw 2 as a mock, and then I'm going to draw this one like this. So here we can see I have a whole bunch of C's. Now I'm going to apply all the H's to it. So this cannot hold any more hydrogen. Carbon only forms 4 bonds. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So this only can hold this many hydrogens, cannot hold any more. So it would be what we call a saturated fat. It is saturated, meaning can't hold any more. All right, fats. Now, on the other hand, a unsaturated fat, if this is my glycerol, here's my two short fatty acid tails. Here's the third one. Okay, as I just told you, carbon can only have 4 bonds. So right now, this carbon already has 3. So we're going to add those 2 on there. So that's 1, 2, 3, 4. 1, 2, 3. Whoops. I got ahead of myself. 1, 2, 3, 4. This carbon already has 2 double bonds on it. 1, 2, 3, 4. So it cannot not have anything else. 1, 2, 3. 1 hydrogen there, 1 hydrogen there. And now I have an unsaturated, at least 1 double bond. We're not going too much into the bonding, guys. We're going to save that for chemistry's class. That's something fun you'll get to do there. So we're just kind of giving you the base terms and some of this stuff, okay? So 2 types of fats, saturated, unsaturated. Saturated is usually a solid at 23 degrees Celsius, aka right around room temperature, and unsaturated fat is usually a liquid at 23 degrees, so right around room temperature. Some examples, like I said, and it says down here, room temperature, saturated fats, butter, animal fats, things like that. A lot of times, unsaturated fat, things like, there's corn oil. I've squeezed a lot of corn. I've never seen any oil come out of that. I wouldn't buy that if I were you. But things like avocado oil, seed oils, nut oils, um, olive oil, all those are great examples and good healthy fats, as they say. All right. Third group, protein. All right. And here, protein we think of, yes, as in muscles, right? We always think of that. But protein does so much more in your body because we'll talk a little bit more about this later. It ends in, we make enzymes. If we didn't have enzymes in our body, we wouldn't be here, period. Okay. So, the majority of the processing takes place, the majority of the processing that takes place in our body is done by a protein, like we just talked about, enzymes. Okay. They can be denatured or changed by heat. Here's the new element that they have, nitrogen. Okay. So you'll have carbon, hydrogen, oxygen, and also nitrogen. All right. And your monomer here is, all right, amino acids. And they end in ine or ine. So like arginine, all right, glutamine, beta-alanine. Okay, that ene at the end lets you know that it is a protein or an amino acid that makes up protein. There are 20 different amino acids found in nature. Amino acids are made up of 3 functional groups, and yes, you'll need to know this. Okay, so you have an amino group, which is going to have the nitrogen that makes it the amino group. You're going to have a carboxylic acid group, or this C double bond O OH. Okay. And then you're going to have an R group, and this will change every single one. Okay. So, I just put AA for amino acid. So they change, in this structural, this R group is going to change every time for every single amino acid. All right. So enzymes are proteins. They regulate things. Enzymes are catalysts. They transport hemoglobin, things like that. The whole reason we can have blood or oxygen really all over our body is the hemoglobin found in your blood. Structural, like I said, skin, hair, bone, nails, muscles, all right, and protective. They also make antibodies and things like that. So once again, we always think about protein being okay, muscles and things like that. It does so many things in your body that we can't even really put it all into this little PowerPoint. Last but not least, nucleic acid. Okay. So this is the building block of life. All right. Your DNA and your RNA are made up of nucleic acids. Okay. So we have CH and O like we've always had. We added nitrogen when we had protein, but now we're going to add phosphorus, all right, because each one of these nucleotides are added up, are put together, and a phosphorus is used for that bonding. Okay. So we have DNA and RNA. We know a little bit about this. We're going to learn more about DNA and RNA in a little bit, but we're just talking about it at a surface level for right now. All right. The monomer is a nucleotide. Okay. We have 5 total, 4 used in both DNA and RNA, but one of them is going to switch. Okay. And here's your basic structure of every single nucleotide. You have a sugar in the middle. It'll be the dinucleic acid or deoxyribonucleic acid or ribonucleic acid. Sorry, little brain fart right there. So sugar is going to be different between the two. You have the phosphate that's going to kind of be this little round thing on the end, and then you have the base, which is the A, the T, the G, or the C. All right. So they were once again 5 phosphate or phosphate group, 5 carbon sugar, and a nitrogen base. And please make note of the shape. Okay. So that is our 4 nucleotides. Like I said, we're kind of keeping it on the surface right now. We're not delving too deep into these because in a couple units we will. So we're just keeping it nice and on the surface at this point. So that's it. I'm sorry I tried to make it as short a video as possible, but that was a lot to slog through. So hit that pause button, do whatever you need to do to just kind of get through these. All right. I'll see you in class.